All right, so this is lesson 6-9, part 2. I was just showing you why I think they had the wrong expression there. And I'm going to get rid of all of that work, and then we're going to relabel this triangle the way it should be. And continue with proving that when we connect the midpoints, we get another smaller equilateral triangle. All right, so now this C is actually 2a, and then 2a times the square root of 3 are the coordinates. And that's because this is the height of that triangle, the distance from F to C. So the value on the y-axis. And then B would be 4a and 0. And A is, of course, 0, 0 at the origin. And so there's our triangle. Now we want to prove that DEF is an equilateral triangle. To do that, first thing we're going to do is find the midpoints. Then we're going to use the midpoints and the distance formula to show that those three are congruent. So then by definition of equilateral, we'll know that triangle DEF is an equilateral triangle. So let's start by finding the midpoints. So we have midpoint D, and midpoint D we get by adding the x-coordinates together and dividing by 2, and then adding the y-coordinates together and dividing by 2. If we do that, we end up with 2a plus 0 divided by 2, and then 2a times the square root of 3 plus 0 divided by 2, which if we simplify that, 2a plus 0 is 2a divided by 2 is just a. And then 2a times the square root of 3 plus 0 is 2a times the square root of 3. And then if we divide that by 2, we just get a times the square root of 3. And then for E, adding the x-coordinates together, for E, we have to add the C and the B x-coordinates, so we get 2a plus 4a, or our x-coordinates. Divide that by 2. And our y-coordinates are 2a square root of 3 plus 0. And divide that by 2. And 2a plus 4a is 6a divided by 2 is 3a. And then the y-coordinate is just a times the square root of 3 like the last one. And our F. Our F, we got to add our A and B coordinates together, so 4a plus, oops, our A and our B, 4a plus 0. Divide that by 2, and our y coordinates are 0 and 0. Divide that by 2, and we end up with 2a and 0, or F. Okay, now that we have those coordinates, we can find our distances. And our distances are our distance from D to E is equal to the square root, using the distance formula, from D to E, so I have to use these points. Subtracting those, I do 3a minus a. Square that, and then I need to subtract my y-coordinates, and that would be a square root of 3 minus a square root of 3. Square that, and if I simplify that, I get 3a minus a is 2a, and if I square that, I get 4a squared plus, and this is just 0, so I don't really need to add to that. So I have 4a squared, or if we go back and, well, square root of 4 is 2, and the square root of a squared is a, so that's just 2a. So our distance from D to E is 2a. Okay? And if you think about it, our base was 4a, and if you think about the mid-segment theorem, that kind of makes sense as half of that. So now we're going to do our distance from D to F. So now I'm using this x-coordinate and this x-coordinate, the simplified form of those. So 2a and a, we have to subtract those, 2a minus a, and square it. And we have to do the y-coordinates there, which are 0 and a square root of 3. And 2a minus a is just a squared, plus a times square root of 3 minus 0 is a square root of 3. That's squared. And that's equal to, let's think about this. If we take the square root of 3 squared, that's just 3, and then a squared makes 3a squared. And 3a squared plus a squared is 4a squared. And the square root of 4a squared is just 2a. So we get 2a again, so we've shown that two of the distances are the same. The last one to do is EF. And EF is equal to E and F, that would be that one and that one. So 3a squared, or 3a minus 2a squared plus, and subtract our y-coordinates. That would be a square root of 3 minus 0 squared. And 3a minus 2a is just a squared, just like in the last one. And then that is the same as the last one too, and we saw what happened there. We ended up with 3a squared, and then when we add those together we get 4a squared, and the square root of 4a squared is just 2a again. So at this point we can say that triangle AEF is equilateral because of the distance formula, the midpoint formula, and the definition of equilateral. All right. Problem 2, you're going to write a coordinate proof of the mid-segment theorem. I'll let you go ahead and try that, and I'll put up the answers for you so you can check. Actually, let me help you get some coordinates here, just so you know that might be hard. But basically, this is any triangle, so our distances have to be like 3 different variables. This is 0, 0, that's not a problem. Sure. Our coordinates for A, let's just call that, and we're doing the midpoint formula here, so we're going to be dividing by 2, so let's call A 2A and 0. And then B, we're going to call distance on the x-axis as 2B, and then we'll call the distance on the y-axis as 2C. So we have 3 different distances there, okay? And we made those multiples of 2 so that we can use midpoint formula and divide by 2. All right, so now, as I do that, we can go ahead and find these midpoints. And to do that, you just add the x-coordinates together and divide by 2. 2b plus 0 is 2b, divided by 2 is just b. Okay, 2c plus 0 is 2c, divided by 2 is c. Likewise, we can find e. E is going to be 2a plus 2b, and I'll just do my work down here, divided by 2. But that's just a plus b. And then the other one is 2c plus 0, and divided by 2 is just c. So there's my coordinates. All right. So now, and I skipped to that. I'll fill those in quickly. All right, so now we're going to use the slope formula to figure out whether or not those two lines are parallel. We need those lines to be parallel for that to be a mid-segment. So using the slope formula, EF, those are my x-coordinates, so that's going to go on the bottom, a plus b minus b. And my y-coordinates, c minus d, are going to go on top. And that's equal to 0 over a, which of course is equal to 0. And then the slope of AC, that's the bottom line, so we want to make sure that's parallel. C is 0, 0, A is 2A, 0. So our y values are both 0, and our x value, one is 2A and the other is 0. And so we get 0 over 2A, which of course is 0. And so we know that EF is parallel with AC because they have the same slope. And we know that lines with the same slope are parallel. All right, so now we're going to use the distance formula to see if EF is 1/2 of AC. And so I'm going to do EF is equal to A plus B minus B, and C minus C there. And that's equal to A squared plus 0 squared. And AC is equal to 2A minus 0 plus 0 minus 0, which is equal to 2A. And so 1/2 AC is equal to 1/2 times 2A, which is equal to A, which is equal to EF. So the length of the segment is 1/2 the length of the base. All right, lesson check. I'm going to have to let you try this, and you can check back with your answer. Okay, see you tomorrow.